Alrighty, so here's the problem. I'm going to scoot over so you can read all of it. Again, stop this video so you can practice these problems and then check with me. Alrighty, so let's see what you got here. Alrighty, so let's talk average. Don't you add the numbers together and divide by the head count of numbers, and that creates an average? So how many scores are we talking about? 2. So you got basketball game, she made 24 points. And then she's going to have another game, and the question is how many points can she score in the second game? So how many points did she make in the first game? 24. How many points did she make in the second game? I don't know. Wouldn't you divide that by 2? Right? And what did they say that she wanted? She wanted an average of 20. It's over here. It's way over there. So an average of 20 points for both games. She will receive her trophy. What if she makes more than 20, averages more than 20 points? Would she not get a trophy? Can you get too many points and not get a trophy? So I'm assuming greater than or equal to 20 would be acceptable. She can have extra points. They probably just don't want less points. So now we've got an equation. Now how do you deal with all these dang fractions? So how do you get rid of a fraction? Now, that's a good question. Now you could put this thing over 1 and cross multiply. Or we can multiply by the reciprocal of 2 and just get rid of this completely and just keep our whole number stuff going on. So I think that's my game plan. So I'm going to put a bracket. I know, cheater, right? And isn't that like 1 over 2? The fraction, like 1/2. So what if I multiply this thing by 2 over 1? The whole thing. That's both sides. Or I could put a bracket here and put 2 over 1 to both sides. So that way you could really see the steps. Wouldn't this 2 and this 2 cancel each other out? So guess what you're left with? 24 plus x. Boy, nothing like getting rid of fractions. Keep your simple. What's 20 times 2? 40. Well, that's real nice to get rid of. And by the way, that would work all the time. All those years long ago. Solve. So here's your triangle. This time I'll get the positive in there. Wouldn't that be minus 24 minus 24? 0. X. Symbol. What's 40 minus 24? What's 40 minus 20? 20. What's 20 minus 4? 16 maybe? Positive or negative? I think positive. So what does this mean in words? So X is what? The game. So her next game, she can have more or equal to 16. So if she makes 16 points, she'll get a trophy. If she makes 17, she'll get a trophy. If she makes 15, she won't. So she must make 16 points or more to get a trophy. Trophy. Love that spelling. Alrighty, let's go to question 14. This is taking forever. Y'all better love me. Which of the following is not a solution to this problem? How could you have more than one answer to an equation? I mean, that's a good question. Oh, that's an inequality. So that means you could be bigger or equal to a certain number, and then the answers after that would be acceptable. Good point. All right, making sure everybody's with me. All right, let's do this problem. Do you have the variables on the left? You do. I would put a triangle here, especially if you're playing with these kind of questions. Don't you do minus 7, minus 7? Yeah. Do you do that to both sides? Only if you want to pass. Symbol. What's 19 minus 7? 12? Because 7 plus 2 is 9. Positive or negative? Positive, because the 19's bigger. When you divide by negative 2? 6, but let's talk negatives. Oops, I got an equal here. Get rid of that. So 12 divided by 2 is 6. So this was divided by negative, negative. That makes that positive. By the way, I divided by negative, so you can switch that right now while I'm thinking about it. And that's positive, that's negative. So wouldn't this be negative 6? Yep. And so then let's think about that on a number line. I know it doesn't have one, but maybe that might help us. Here's 0. Here's negative 6. I'll circle it and fill it in. And that way is your left. So all these answers work. So who doesn't work? So where's negative 7 at? Wouldn't that be 0, 1, 2, 3, 4, 5, 6, 7? Well, that one's on this side. That one works. Negative 10, wouldn't that be over here? That one works. Negative 6, well, it's actually shaded in. That one works. 2, negative, it's on that side. That one's not going to work. So this helps a lot. Be sure to do that. Let's do another one. Question 15. So you're going to have to write the equation, and it's a compound inequality at that. Which one of these is and? Which one of these is or? Well, this one's and. The ones going opposite are or. So these are and. These are or. Heads up on that. Alrighty. I'm going to put, for the and, the x goes in the middle. And then you read it off both directions. So that's a 6 and that's a negative 4. I would put the numbers in least to greatest. So are you bigger than 6 or less than 6? So x is less than 6. Are you bigger than negative 4? Yes. So x is bigger than negative 4. What about the close part? Better close the 6. And that's pretty simple. I kind of like those. Let's do the next ones. So I can put the word or. I can put x. I can put the numbers negative 3. And I can put the number 3. So actually that's not too bad. All you have to do is find the symbols. And which way is this one going? Because I always like this way first because it's I don't know, normal. I would say greater and equal to. That one's pretty good. What about this one? It's definitely equal to. I would say it's less. X is less than negative 3. And it's solid, so an equal to. Pretty simple. Question 17. This is coming from chapter 1 when you had to translate, like right here. And what happens when you do less than? Thank you. You switch the order around. And how many variables can you have an equation if you want to solve it? 1. Good point. And what does perimeter mean? Sorry, add all sides, right? So heads up, we got lots of things going on. So I'm going to translate that out. That's going to be 3 times w minus 4. So I'm going to go ahead and write that over here. 3 times w minus 4. If we're going to use w, you're going to have to make this also w. You can only have one variable, you can't have two. So the length stands for 3w minus 4, and the width stands for w. So we're going to go ahead and write the equation. I can actually write it two ways. I can use multiplication or addition. I'm going to probably use both. So I'm going to have 2 sets of 3w minus 4, and I have 2 sets of w, and all of that equals 56. Now if you want addition, you would have 3w plus, oops, not plus. Well, I guess I could make it plus, but I'll just be nice. 3w minus 4 plus 3w minus 4 plus w equals 56. How many w's do you have? 3 and 3, 6, 7, 8. 8 w's plus, isn't that negative 4, negative 4? Negative 8 equals 56. Wouldn't that be your triangle? Sure it would. And so that's plus 8 plus 8. That's 8w equals 56 plus 8 would be 60 plus 4. So how about 64? Divide by 8, divide by 8. W equals 8, because 8 times 8 is 64. So if the width is 8, what is the length? We have to go back to that equation. So that's going to be 3 times 8, because it says so, minus 4. Well, 8 times 3 is 24, minus 4, how about 20? And that is your length. There you go. Let's do another one. Question 18. You have that equation. Find the value of 4x minus 2. So you're going to have to find x, then you're going to take that value and put it in. Be mindful, the answer of x would be wrong. I need x to plug in here, multiply by 4, subtract 2. That will be your new answer. Yep, 2 parts. Those are fun. So find x, found it. So wouldn't that be plus 12 plus 12? So wouldn't that be x equals, what's 12 plus 7? 19 maybe? So that was pretty good. I can assure you, times 100, 19's an answer choice. Don't pick it. Come back over here. So what's 4 times 19 minus 2? Well, let's see. 19 times 4. 9 times 4 is 36. 4, 5, 6, 7. 76. What is 76 minus 2? 74. And that is your answer. Question 19. Which situation best represents this equation? So before we get too carried away with reading all these stories and confusing yourself, that's a subtract sign, right? That's a takeaway. That would be like a haircut. When you have a haircut day, your hair don't grow. Whatever happened, it disappeared. This is your total. This is your total after you did something. After the event. This was your total before the event started. I don't even know what the event is. Alrighty. Well, let's read. Somebody bought a bag of candy that contains 40 pieces. Okay. But isn't X the grand total? She ate 15 pieces of candy. Wouldn't that represent eat? Because if you eat it, it should disappear off your plate. Because if it's not disappearing, I'd stop eating it. This one's wrong. Because it would say she ate 40 pieces. She ate 15 pieces. That part's wrong. That part's wrong. We can stop reading. A's out. Next. Somebody took 40 pieces of candy from a bag of candy that contained this many pieces. So he took 40 pieces. Wouldn't that be take away 40 pieces? The bag of candy contained this many pieces. Wouldn't that be the total? There were 15 pieces of candy left. I don't have a problem with this one, but I'm not sure. Next one. Somebody has 40 pieces of candy. I have a problem. The total is X. This is not the total. Kevin had 15 less pieces of candy than Andrew. Less? No. Somebody had 40 pieces. No. Nobody had 40 pieces of candy. Somebody took 40 pieces of candy. Has 40 pieces. No. See, this one has 40 pieces. Preston took 40. True. Because it has X. See, this one's true. It had 40 pieces. But she didn't eat 15. The answer is B. Alrighty, next question. The ratio of skateboard to bike in extreme sports is 7:2. There's 91 skateboarders. How many bikes? Now, let's be honest. That's a 7th grade question. Before you do anything, if you don't label this stuff, I'm going to fuss at you. So you got skate over bike. That's the numerator. Oops, sorry. That's the numerator. That's the denominator. 7/2. And then 91 skateboard. So that would go here. And that's your X. So, what do you remember about proportions? Yep, it was all taught last year. Yep, they were fun. So I teach them a little different. I'm really not into the butterflies. That's a science thing. So here's my X. I'm going to scoot over. And when I say over, I mean across. I'm going to draw start, diagonal, divide. I said start, diagonal, divide. And I always start at the variable and I move across. So start, diagonal, divide. And so I'm going to go ahead and write that. That's 2 times 91 divided by 7. And that is how you do that problem. Does anybody know what 7 times something is 91 by chance? 13. So I'm going to play factor trees. So I'm going to keep my 2. I'm going to change 91 to 7 times 13 divided by 7. And wouldn't 7 divided by 7 be 1? So 13 times 2 is the answer. 26. 26 what? Bikes. For those of you that are lost, you'll go ahead and find lots of dividing, lots of multiplying, then some dividing. Catch the next video.